Okay, I hope I can give you a little bit of help on the groundwater lab here. We're going to talk about Darcy's Law today, and I hope you've listened to the video that deals with the groundwater before this, but I want to go over the key ideas anyway. Darcy's Law here, this particular equation, calculates the velocity at which the groundwater moves based on K, the permeability or hydraulic conductivity of the water, N, the porosity, and delta H over delta L, or dH over dL, which is the gradient. So we're going to figure out how fast some things are by applying it to a real-world problem. So what I want us to do is to skip down to the last next to last page where you can see the map. What we're looking at when we look at this map is this is the elevation of the water table. This one is 1460, this one's 1470, 1480. So this is not the ground surface, not the ground surface. This is the water table down underneath the ground. So up on the ground surface are some roads, some gasoline stations, and then we have two wells, well 2 and well 1. They're pumping out the groundwater. Down here is our map scale from 0 to 500, so this distance is 500 feet. Our contour interval, remember, is the difference between adjacent contours, is 10 feet, right? And the direction, this is the new part, of flow is going to be perpendicular to the contour lines. So let's see if we can do some, we'll do the best to construct some of these. Let's see. Let's start at gas station A. Which way is downhill? Perpendicular to the flow line. Here we go. Next one here. It's going under the road. Remember, it goes here, a right angle, goes to a right angle here. Notice it bends a little bit. Bends a little more here, bends a little bit more here, bends a little bit. Oh, boom, right into well number 1, right? What this is saying to us is that if we have a leak starting at gasoline station A, the downhill direction takes us right into well 1. Okay, so far so good. Next thing that we're going to do is we're going to look at this scale. We're going to look at the contours. Let's see what the gradient would be, rise over run. So we start at 1490, right? We go down 10, 20, 30, 40, 50, 60. Oh, it's not up to 70. We'll call it 65, halfway in between. You good with that? I hope so. So 65 feet is our change in the height of the water table. And here's 500 feet, so if we went 500-ish, 1,000, say 50, let's call it 1,500 feet. You don't have to be super precise. So our gradient here is going to be 65 over 1,500. Okay, so from that we're going to calculate our groundwater velocity using Darcy's Law. Okay, let me stop right there, and then we will move on to another part of the problem in just a few minutes. But give that a try and see what you can plug through.